Okay, so we've already sketched our parabola, but we need to sketch the area to be found and then some labels. So we have this area bounded by curves and area bounded by parabola and x-axis line. This is x-axis line 1, 2, 3. We have here 3. So our area bounded by this curve is from 1 to 3. From 1 to 3. Right? Then we need to find this area bounded by the parabola and x-axis 1 to 3. X-axis line 1 to 3. Okay. Yan. Show representative strips or elements. So we need to show the representative strips. So say this is our representative strip represented by the rectangle. So this is our strip. Usually this strip is our Y, and this thing here is our dx. Right? Okay, and this area is our R, and this curve here is y is equal to x squared plus 1. Okay, so from here the next step is to approximate the area assuming it's rectangle. So we have length times width. Let the area of this element be dA equals to dA. So it says here that let's let this area is equal to the derivative of A. So we have dA is equal to the this element here. So we have the dx, and then our length here, which is yung ating y. So we have y dx, wherein our y in terms of function of x is equal to function of x. This is our function of x is equal to x squared plus 1, then our dx, and then this is our a. To get the area of the region, integrate dA from lower limit to the upper limit. So we need to determine the area represented by the strips from lower limit up to higher limit. So from lower limit, which is equal to 1, so we need to integrate now this from 1 until it sum all the strips up to 3. Okay, so by doing that, we have a is equal to the integral of x squared plus 1 dx from 1 to 3. So we have to integrate this. We have x cubed all over 3 plus 1 dx is just x from 1 to 3. Then our next step here is to substitute the value of our limits, upper limit minus the lower limit. So we have 3 cubed all over 3 plus 3 minus the lower limit. We have the 1 cubed all over 3 plus 1. And then plugging all these numbers, we have 27 divide 3 plus 3 minus 1/3 plus 1. Then we have 27 divided 3, which is 9 plus 3. We have 12 minus 1/3 plus 1. We have 1/3 plus 3 over 3, or 4 over 3. Right? Then 12 minus 4 over 3. We have over 3, 12 times 3, we have 36 minus 4. Our A is equal to 32 all over 3 square units. So this is now the area of this region bounded by the curve yx squared plus 1 and x-axis from x is equal to 1 to x is equal to 3. Okay. So that is one of the application of our integration, to find the area of this irregular shape bounded by this curve. Okay. So by the way, as you can see here, using our definite integral, what we've done here is to minus this area minus this area, right? Since if you will notice, if you can notice, say this is our x and y axis. Sorry for my drawing. This is our parabola. Say that is graphically correct. Assume that my drawing is graphically correct. See, this is our area from 3. Then as you can see here, if I compute my area from 3, then area bounded by this is this whole term. And then if this whole term here minus this point minus this point, then we can now have our desired region, right? That's why we have to minus the upper limit to our upper limit to determine the delta from point 1 to point 2. Okay, you can now have this region only because this is what we want to determine, this region alone. Okay, so once again, we have a general procedure: sketch, then label, show some representative strips or element of our rectangle, representative strips or element, then approximate the area using length times width and let the area of this element equal to dA. Then our length times width, our length y is equal to this function of x, and our width is dx. Then integrate to get the summation or the totality of this element here, these small strips, our rectangular small strips or the element. Okay, so if you got the totality, then need to get its area having the limit from 1 to 3, and our value is 32 over 3 square units. So all in all, this area bounded by this curve, the parabola, and x-axis line of axis from 1 to 3 is about 32.3, I mean 32 over 3 square units.